So for question 5, we have a velocity vector, t squared sine t minus t cosine t, and cosine t plus t sine t. And we're trying to find v double prime of t, and also the position vector r of t. So we have v of t. First we want to find the first derivative. So doing that, we would get 2t here. Derivative of sine would be cosine t, and then minus, so I'm going to pull that minus sign out, so 1 times the derivative of the second would be negative t sine t, plus the second times the derivative of the first. Derivative of t is just 1, so plus cosine t. I'm running out of space, so I will put it to the bottom. Now for this part right here, cosine t, derivative of that would be, negative sine t. And then plus t sine of t, so 1 times the derivative of second, which would be t cosine t, plus the second times the derivative of the first. So just simplify it a little bit. We have 2t cosine t plus t sine t minus cosine t. So we see that these cancel. And then we have negative sine t plus t cosine t plus sine t. And we see that these cancel. So to simplify even more, we have 2t, t sine t, t cosine t. So that is our v prime of t. But we need v double prime, so we need to do the same thing again. So v double prime would give us 2. And here, so 1 times the derivative of the second, t cosine t, plus the second times the derivative of the first, plus sine t. And the same thing here. So this would be negative t sine t plus cosine t. And here we have our second derivative. So that answers this part. So the second part, r of t, our position vector, we get that by taking the integral of our velocity vector. So starting that, we are trying to do 2t dt, comma, this is all in the vector. And we got cosine, sorry, I wrote this wrong. Wait, did I write this? Let's see. Yes, I did the wrong vector, sorry about that. Looking at the wrong vector. So we're looking at this vector, v of t. We have t squared dt. We have integral of sine t minus t cosine t dt. And we have integral of cosine t plus t sine t dt. And solving for that, we would get our position vector. So we can do the first one. First one's pretty easy. First part of this would be t3 over 3 plus some constant. We'll call that c1. So that's the answer to the first component. The second component here, I'll do this in blue. Right? We see that we're going to need we can break this up into 2 integrals, but we're going to need this part, this t cosine t. So if I do this on the side, cosine t dt, because we're going to eventually need that, we can use our integration by parts, setting u equal to t, and dv equal to cosine t dt. du would be equal to dt, and v would be equal to negative sine t, or I'm sorry, v would be equal to sine t. So if we do our rule, v times u, which would be t sine t, minus the integral of v du, is just sine t dt. Integral of sine would be negative cosine, but this negative here would change to positive, so we got t sine t plus cosine t for this part. So I'm going to try to bring this over here. So integral of sine would be negative cosine t, and then this negative sign will change our answer here. We just solved for that, plus cosine t. So simplifying this, distributing this negative, we see we have two negative cosine t's. So we have negative t sine t minus 2 cosine t, plus some constant c2. So that solves the second part. I'll do this third part in red. We see that we're going to need a t sine t integral. So on this again, I'll do that on the side. T sine t dt. Do the same exact thing. U equals t. dv is equal to sine t dt. du would be equal to dt. Our v integral sine would be negative cosine t. So we do our v times u, which is negative t cosine t, minus the integral of v du. There's a minus sign here, so now I'm just going to change this to a positive, bringing that negative sign out. Cosine t dt. Integral of cosine would be sine, so negative t cosine t plus sine t. We answered to that. So I'm going to try bringing this over here. We have an integral of cosine t, which is just a positive sine t, plus what we just found, negative t cosine t plus sine t. You see that we have two positive sine t's, so we're going to combine them. We have negative cosine t plus 2 sine t plus some constant. I'll call that C3. So now you see we found each component, so we can just put them together. Our position vector would be our first component we found right here, t cubed over 3 plus c1. Our second component in blue we found right here, negative t sine t minus 2 cosine t plus some constant c2. And our third component we just found, negative t cosine t plus 2 sine t plus some constant, c3. We have a constant. We can say that let our some c vector be equal to c1, c2, and c3. Therefore, we can pull that out. So t cubed over 3, negative t sine t minus 2 cosine t, and negative t cosine t plus 2 sine t plus our c vector. And this would be our position vector.